So before we begin, I just wanted to give our panelists an opportunity to introduce themselves. So we'll start with Lee.
Sure. So I'm Lee Krause. I'm the CEO and president of Rampart AI. I have 30 years experience um, in software development. In the last 10 years, we really focused on the cybersecurity problem. And when we approached it, we went to tackle the really hard problem, tackling the problem of can we prevent cyber events and increase the resiliency of software without rewriting the code and without any signature or known information about what we're protecting against. We consider that to be the real hard problem, the zero-day types attack that will take your system down. And so that really is the fundamental premise of Rampart AI, is to ultimately allow us to protect against things that we don't know about. And I think that's pretty exciting.
Perfect. Sam?
Yeah, my name is Sam Curry. I'm the Chief Security Officer of Cybereason by day and President of the Cybereason government entity. I'm also a visiting fellow at the National Security Institute. I've been knocking around in cyber for longer than we've called it that, 30 years as well, Lee, doing a variety of roles. And I just love everything about application security. And I happen to be friends with the folks here, so I thought it'd be good to have a conversation together.
Perfect. And then we have Jacob here who's going to be doing the demo at the end. I don't know if Jacob, do you want to introduce yourself as well?
Sure. So I'm the CPO of Rampart AI. I don't quite have the lengthy careers of the other folks on the panel, but I do have a lot of experience in the cybersec domain. And we've been working on the technology underpinning all this for about 10 years now. So what you're seeing today is kind of the fruition of 10 years worth of work, and we hope you find it interesting and valuable.
Perfect. So if you haven't caught this yet, today we're talking about application resiliency. We believe the big question today is how can you better protect your application from bad actors, how past attacks are impacting the future of security, and what we can do to secure applications. So let's dive in. Lee, let's start with you. What are the problems you are seeing today with our current security solutions that are not giving businesses the security needed to defend against bad actors?
I think that's a really good question. So when I rip that apart, I think that it's obvious that the solutions that exist today aren't solving the problem. I think if you look at SolarWinds or Log4j particular attacks, we can see that we had plenty of tools in place, but yet they created massive problems for the industry. And so to me, it kind of shows that the current tool sets really aren't keeping pace with attackers and attacks of the future. I think that's just a really good indicator to think about. I also think when we look at it is that I view cybersecurity as a layered approach. That's not just one tool is going to solve the problem. It's a layered approach. And the area that we're most interested right now is at the application layer. And I think one of the things to think about is that that's really where a lot of your emergent threats are going to come from, is from the applications themselves. And I'd like to just kind of turn around a quote that Hector had, which was, his quote was, what's the easiest way to break through a firewall? And the solution was, have the firewall call you. Well, I think that's still very true for applications. What's the easiest way to have application issues is for the application to ultimately phone home and call you. So the problem, the malware exists within the application itself. And I think that's a real problem in the future. When we look at SolarWinds, you can immediately say it was a supply chain attack. But I think really what we've seen is that it was an attack where they took trusted code and allowed it to proliferate through the entire development process. And it actually even showed that the current, DevSecOps tools are only good at understanding what's being tested or what they're working on, because it easily flew through the whole DevSecOps process, even made it through all the way through tests and into operational production, right? So something needs to change to ensure that problems like that can't occur in the future. And I think that the solution there is to be able to monitor applications at runtime and ensure they're operating as expected. I think that's an incredibly key component of it. I also think when you look for Log4j, Log4j was an example where it was an attack for an obscure library that ultimately created havoc within the industry. So here's a case where, because it wasn't a known signature, that it ultimately caused an immense amount of problems. And so again, how do we protect against attacks without knowing anything about them is key. So I think that that's really kind of the future of what we're going to see, is more sophisticated attacks that are happening at the application level, that are taking advantage of systems and ultimately holding owners of the application at ransom to say, if you're not paying up, they're not going to allow your application to work. That's what I see the future.
Perfect. So if you guys have any questions based on Lee's response, please, you can put it in the chat now. And we're going to move on to Sam. So our question for you is, ransomware is a great example of bad actors at work. What are some of the top methods ransomware gangs are using today to breach the network?
Yeah, so I mean, there's a lot here to unpack, but generally, I just want to add to something Lee said. I think we as an industry we're kind of flat-footed. We're not innovating enough and adapting enough, while the attackers they have a much greater rate of innovation and advancement collectively. It doesn't have to be that way, but it is. And so they pick their points of attack and they go after things that we just haven't thought about, how to update or how to build a nimble scheme for improving. Now, ransomware in particular, there's two major components in the setup and the execution of ransomware, and then there's what comes afterwards. The first is the distribution of it. It's the how do you, and that's really a malicious operation. It's a malop, if you will, not malware. It's people with their tools distributing and getting through networks to systems. Think of it like placing bombs for simultaneous detonation. And then there's the detonation. That's the malware, really. If it's only done partially, or if it's not done simultaneously, then there's a chance, an increasing chance, that the victim will have a partial survival or will be able to respond in time. And so what they try to do is they try to get their operations to deliver it rapidly, put it in place, and then detonate. We also see, sometimes it's called double or triple extortion. It is the attempt to extract a ransom and to embarrass the target if they don't, to publish their information, like Conti does on their website. That's the stuff that happens afterwards. And they target. We just saw the LA Unified School District get targeted by a reprehensible group who go after explicitly K through 12 education. Think about that. They go after schools because they know that schools have non-homogeneous environments, often strange things happening because of labs and students. Sometimes, people are cutting their teeth as hackers in those environments, in courses, in red team courses, things like that. And they know that they can absolutely take advantage of those institutions. They used to go after municipalities. And so it's pretty horrible, but there's a lot of innovation going on in the tools. Sometimes they're less sophisticated ransomware actors, like the ones that went after the LA Unified School District. They were pretty much script kiddies running existing things, just using tools that have existed for ages, like Hello Kitty, for instance. So they're evolving, and now they've aligned geopolitically. So what we see is the sort of neutral cyber criminals have Anonymous is aligned more with Ukraine. Places like Conti have aligned more with Russia or the conflict over there, and they're looking to sow and wreak havoc. So there's a lot going on, a lot to unpack there. I hope I didn't drag it on too long, but I would emphasize there's human beings on the other side who are innovating and picking and choosing the time and means of their attack. And that's second order chaos. It's far worse than something like a hurricane or an earthquake, because you can prepare for those. You can build insurance, you can build better codes for buildings, you can build risk management for those. But human beings are the most devious opponents we've ever faced. And as such, if they're innovating faster than defenders collectively, then the problem's only going to get worse.
Perfect. Very well said. So this is for any one of our panelists. Are the bad actors using methods of old with more creativity to breach organizations today? For example, phishing, misinformation, socially engineered attacks. Could you both speak on that?
So I guess I'll take it
Go
first.
for it. Yeah.
So I think if you look again, if you look at SolarWinds, I don't think it was necessarily new malware they were using. It was just being used and delivered in a new form. I think that right now, as long as it's working, people are going to continue to do it. And I think it gets to what Sam said. There, you're basically, as long as you're successful, you're going to keep doing it. And as soon as you're forced to change your game, they ultimately modify it. Again, I think the biggest thing that occurred that was earth-shattering is that SolarWinds allowed what was considered to be trusted code to be entered into a baseline, and people just assumed it was trusted. And I think that same notion of how many other gifts exist in third-party code or operating systems that are already in there that we're unaware of, and we think just because somebody signed off on it or whatever, we think it's safe. And that's not even taking into account any type of real-time attack that can occur in the future. So I think that from a defensive position, it's really a hard thing. You're getting hit with anyone looking at what's the easiest way to get in. Just use a Metasploit kind of tool set and just search and say who's vulnerable with existing vulnerabilities. And then you also have true actors and criminal gangs that are looking to truly exploit. And in that case, they're innovating, and they'll continue to innovate because that's what's driving them.
Yeah, Daphne, I'm going to build on what Lee said again. I'm going to say, look, like he said, if it works, why would you stop using it? But there's often incremental innovation. So it's iterations, it's tuning. But identity continues to be a part of every attack. Like the vast majority of attacks, maybe not every, but the vast majority of attacks include some component where there's an identity compromise. It might be the initial vector. It might be something along the attack chain. I think one of the premises that Lee mentioned earlier is that now we're starting to see applications in every attack chain, right? That it's so it might begin with an identity, but ultimately it gets to something like an application, right? And so there's some things, call them the usual suspects, that are turning up in every kill chain. The other thing that I will say is even supply chain attacks are not new. Not Petya, if you remember that, folks. It was a supply chain attack. A lot of folks don't realize that. It was the EmiDoc financial application that was exploited, and everybody who did business with the government anyone who did business in the Ukraine had to pay taxes through this package, and the Russians knew it, and NotPetya was delivered through this application so that it hit everything, all the private sector and public sector in the Ukraine, but also people who did business with the Ukraine. That's how it went international. And so we're talking 2017, 5 years ago. We were looking at an instance of supply chain attack. We didn't call it that. And I'm going to go a step further here and say, you can imagine in your head a triage list of the most attractive vectors for supply chain attacks. And the ones that are most attractive are going to have a few criteria. They're going to be ubiquitous everywhere. They're going to be powerful. They're going to be largely ignored, and they're going to be easy to reach. So what were the first ones? PowerShell. Of course it was PowerShell. That, by the way, if you think about it, is a supply chain attack. If you think about it the right way, it's there, it's everywhere. MS Office scripting languages, but eventually you get to things like Log4j. There's these little, call them diamonds in the rough for the hackers to go find and exploit, and think of it. They want to find these things that can go far, fast, powerfully for little effort. And if you did a triage list of what those things are by doing an inventory of components and software around the world, you'd probably have a hit list of what they're going to go after or have gone after. I would use an iceberg analogy, except that I think 10% is probably too big. It's probably more like we know about 1 or 2% of ways through enterprises and through networks that get discovered. So I see Hector joined us, and so I'll shut up now. And feel free to ask him a question, but give him the opportunity of hearing the question.
Well, yes, as I would see, one of our esteemed panelists has joined us. And like a mid-chat rise here for everyone. I'll let Hector Monsegur introduce himself, and then we do, in fact, have some questions for you.
Sure. So my name is Hector Monsegur, Director of Research at Alacrinet. And At one point I was the bad guy. So I'm a former adversary, and I'm here to share that perspective with you guys. And for the record, I've been here the whole time. I just had a different name on the screen, so you probably, you guys are
Identity compromise right there. Who were you, Hector?
Oh, listen, it starts with a C. I'll leave it at that. But
I think I know who. I think I know who it was, but I wasn't sure, and I wanted you to reveal yourself just like you did now, so it's all part of the plan.
see, that is great security hygiene by Daphne. I hope you guys in the audience learned that.
But so Hector, we have a special question for you.
Okay.
So since you had such like a background in application security, besides as you have mentioned yourself before, how do you think we can better protect applications from bad actors? What are some of the attack methods that you are seeing making through all the defenses?
Well, we have to look at it I like to look at things historically, right? So for quite some time, especially during my time as a bad guy, SQL injections were all the rage. That was kind of a daily thing there. But now, when you start looking at HackerOne or any other, bug bounty feeds, you're seeing a ton of information disclosures. You're seeing a ton of insecure direct object references or IDORs, which is, essentially an access control issue or authorization control issue. There's a whole bunch of different ways to look at it. But that's kind of what I'm seeing in terms of trends. Yeah. The other thing is going to be access controls in general. Can a user, if they get compromised, or if an adversary creates an account on our system, are they able to move laterally or escalate privileges or move upstream? And so you really have to look at dealing with these problems, these questions, before you even go into production. The whole DevOps experience is extremely important for identifying some of these, or including tools that'll help you, mitigate some of these. For a long time, a lot of organizations relied on static systems, right? Signature-based systems like Monsegur, and that's fine. Well, it's fine for back then. Now, what you see is companies opting to use something like Cloudflare or Secureye because they're offering, an extensive, solid signature database, as extensive as you can go. But as everyone should be aware by now, that blacklists usually take you as far as possible, and there's never really a full coverage. So yeah, so those are my perspectives on what I'm seeing today, and how to deal with some of those issues.
Perfect. We always.
By the way, that happened with Uber. That happened with Uber, at least allegedly, right? None of us were on the inside at Uber, but everyone's talking about the MFA exhaustion. Really, that was just the front door. What actually happened was they had hard-coded passwords that let them get to the vault, and then it was all over.
Oh yeah, no. See, the thing is that a lot of and listen, I'm not here to point blame at anybody, but the reality is that a lot of organizations kind of skirted through time, putting that initial, that initial security fence, right? It's a security fence, whatever that is, okay? And they're like, well, I think that's good enough. But the reality is, it really not is. It really is not. You have to really look at your security program, holistically, or from as many angles as possible. Because if all you have is an MFA before an attacker could get keys to the kingdom, it's a major problem. So
I have a thing to add to that, Hector. So one of the things that you talked about is moving laterally, becoming persistent. And I think that's a huge problem, because what you're really seeing is someone that's sophisticated is leaving gifts within your applications to ultimately use at a later date. And I think that's an incredibly hard problem for industry to figure out if they've been exploited. I mean, if you use SolarWinds again, they did an awesome job in covering their tracks. They were in and out. Majority of the people didn't even know they were exploited, right? And they could have left many, many gifts behind. How do we ensure that none of those gifts continue to be backdoors or lead to other exploits? How does as an industry, how do we protect against that?
That's what we're all trying to talk about and solve with various different solutions. And kind of going into that, people often say they've applied X solution here or Y solution there, so they should be protected overall. So have organizations been lured into a sense of security that they are, quote, secured for good because they're implementing these different solutions? So that's a question for all panelists.
I
Whoever
really
wants
hope
to start.
not. I suspect the average CISO. Well, first of all, CISOs don't. I'm speaking as one. I don't like when people ask me what keeps me up at night. There's lots of things that keep me up at night, but I have a risk registry, right? And there's nothing in my risk registry that's zero, like nothing. Now, I might have some that are wrong, but most of them are changing. Here's the key thing: every one of them is getting worse over time. The question is how fast. Like everything comes out. I like to think of security measures as having a cost to break for an opponent, right? Hector back in the day had an opportunity cost and a literal cost to break into something. And that cost came down to develop tools and found what have you. And my job is to figure out what's the optimal spend of money to reduce the risk. So nothing's ever zero. But I think the better answer to the question would be, Daphne, that a lot of CISOs are confused as to what is really at risk and what isn't. How fast their controls are degrading. And most of them don't know where the real risk lies. The models get out of date real quick. That's my take.
Yeah, I would jump on that as well. Like, I agree. From all the conversations I've had, and remember, for the audience here, I'm on the offensive side, so I would interface with like Sam Curry, for example, and we would have a conversation about this topic, right? But from my perspective, I also agree that I don't think a lot of CISOs really understand the risk. It doesn't mean that they're terrible at their job. It just means that there's probably some processes in place that need to be improved, or there's some other information that they're probably missing. Now it's up to their, kind of working as a team, figuring out, what kind of gaps are we dealing with? Are there even any gaps? What kind of tools are we using? What's the worst case scenario if the tool is compromised? What if the tool is ineffective? How many steps before an attacker gets keys to the kingdom if they're able to compromise a custom web application that we've created in house that didn't go through any audits, right? So yeah, so that's really my take. I mean, I agree with Sam here. I mean, I think that's the bulk of it. The other thing is, and this is something that is less on the technology and more on the people. When you start to they start to bring in folks who are developers that do not have any, I would say, security experience or experience with cybersecurity in general, in terms of concepts, in terms of good hygiene and so on. Then you're always going to have problems moving forward. This is why I think that I've always been a big proponent and fan of DevOps security and organizations trying to bring someone in that could interface between developers and the security program. I think that goes a very long way, rather than you have a bunch of developers deploying a bunch of AWS scripts or instances and then posting their code from QA straight to production without any sort of testing in between. That's extremely problematic.
I'll just add on that. Just one thing is that if you look at the current vulnerabilities, I mean, every application you're running is just continuing to get more vulnerabilities. I mean, if you rerun your vulnerability checker 3 months, 6 months down the road, the numbers just keep growing. And that's the tip of the iceberg. That's what we know about. So I think people should really worry about what we don't know about. That's what should really keep you up at night.
There's inevitably going to be vulnerabilities in applications. The rate at which humans find them is both finite and never complete.
Good points all around.
Mm-hmm.
We are kind of rounding up onto the half-hour mark. So we have time for just a couple more questions. For anyone in the audience, feel free to send those in now. At the half-hour mark, we're going to transition to a demo by Jacob. But before then, this is for all panelists. What is the most important step of application resiliency?
Are you speaking? Is that question asked of CISOs as applying it to existing applications in production, or are you asking it from an SDLC perspective, like getting it right in the software development lifecycle? Or maybe I could phrase it as an answer to both. You got to think about both, right? Sorry, Daphne. you're muted, I think.
The first one for you, Sam. The second one for Lee. And then Hector, feel free to interpret it however you'd like. Let's do it that so we cover all of the.
I'm going to answer this by saying that I hate a particular buzz phrase you hear a lot, which is zero trust. I hate it. I believe in least trust, least function, least privilege. One of the best things you can do is try to minimize what the entitlements are in your environment and how things can be accessed by whom, under what conditions. So minimize the complexity in the ways that things can be interacted with in production. You shouldn't have 7 ways to get into production. You should have 1. Not everybody should be able to, only a few. The ways they can do it should be very limited. Now this is painful, right? Because what's the IT department trying to do most of the time? Find ways to connect everything, make sure people can do lots of stuff. Because that's when cool things happen. So it is a political fight as well. But I'll take the production question to say, even though I have opinions on all the rest, the production question should be, make sure that you limit connectivity as much as possible. In fact, in one instance in one of my environments, I just shut the stack down. I don't need Telnet, get the Telnet agent out. I don't need FTP, get it out. Don't let the hacker have that to get egress. Like, just toss it. That's least function. And we all know least privilege. So rather than say zero trust, because there's never zero trust, least trust is a great principle for coming back and moving more and more into production. And I'll let somebody else handle the SDLC side.
Yes, from my side of it, I think that we need to look at what is the weakest link. If you look at what's the weakest link, these DevSecOps tools, really don't earn that trust. And so what you can see then is people getting in your Jira or your Kubernetes or other tools about pipeline. And so if you don't really look at it from what's your weakest link in your production cycle, you're not really going to solve the problem. So from my perspective, I think we need to harden the tool chain and ensure that every aspect of that tool chain, in addition to ensuring that you have the right to be there, that you're using it appropriately, and that we can verify through ultimate testing of the software that it does what it's supposed to do and enforce it at runtime. I think is the key to production.
Yeah, and I definitely appreciate both perspectives from Sam and Lee here. I mean, I don't really have much to add. On the offensive side, my biggest concern is if I'm testing an application, is it going to crash? If it crashes, what's the consequence? I'm always dealing with. Well, one of the requests that I always make is, can we take this web application off of production? Right. I would hope that we're testing a staging server, staging version of the application. But yeah, no, it's absolutely important for these applications to be able to not only maintain stability, but to ensure that the organization has some sort of plan to deal with, well, what's the worst case scenario? If the application crashes or something happens, what can we do from there? How can we be resilient in that capacity? So yeah, a big shout out to Lee and Sam on this topic. I think they have way more experience than I. But I just want to say one thing, Daphne. I am looking forward to the Jacob demos because those are always the best part. So.
Well, we're going to get to that in a second. We actually have a very topical question from the chat that maybe you guys can take a crack at just quickly. So the question is, how do you think the recent conviction of Joe Sullivan, former Uber CSO, will change the posture of CSOs in the near, immediate, and long term, specifically with regards to tooling?
Before I answer that, Daphne, is this recording going out for broadcast?
We can take your answer out if you like, so you can speak candidly.
I did say something if you go look at the Cybereason blog back in 2017, but I will say this. I think there's a lot of fear in the security community about what this means. However, Joe is a lawyer by training. It is my personal opinion that he was doing. And I think a jury has spoken. Now we'll see what happens in the appeal process. There you go. That's mine. I'd love to hear the others, though.
Well, I'll just jump in and say, from someone that has to deal with the either CISOs or CSOs or CIOs pretty much on a daily basis, I would think that, yeah, I think that there's either two directions that we could go with this. Folks are going to be, more approachable when it comes to breaches and or, have a plan in place in case a breach happens and follow a very strict policy. Again, I don't know the Uber's, I don't know their full, the thinking behind what happened, but the second way I would look at it is, I hope that it doesn't scare some of these executives who are probably non-technical people who probably wouldn't like going to jail or being sued, scare them into hiding more, right?
Mm.
Let's hope that that's not the case because we're trying to move forward, not backwards, folks.
There is Hector, you raised something really interesting there because we as CISOs are really, we have an almost at this point fiduciary responsibility. I can't actually say that we do because that's a legal term that means that you have to look out for your customers' rights and interests over those of shareholders.
Mm-hmm.
It's my belief that we're on a path to that as CISOs. In other words, data and the protection of data is a privilege. It's not a right for companies. Now, that will come out in jurisprudence and law, but it's already turning out in some jurisdictions to be true, which means that chief privacy officers, chief data officers, and chief security officers are men and women who have to think about the rights of the owners of that data. And so it's interesting because we aren't lawyers, except for Joe. We generally aren't. The minority of us have a legal background. I do not, for instance. And so how this plays out is really going to be very significant because most of our general counsels think about the company first and about the shareholders first. We don't have a voice yet representing us as a group saying, should we be really representing something else with equal or greater footing?
And I think you hit it right on, and it's extending that whole concept of fiduciary duties, which is that is value to that corporation. For companies that have clients that are holding their data, using their data, selling their data, it's money, right? If your data is held for ransom, it's money. So I think the whole concept of making people more responsible for breaches and things of that nature, I think will create greater awareness and create change if you realize that you're responsible. And I think one of the things responsibility is important. And it may be a painful step to get through, but it needs to happen. That's just my opinion.
Perfect. Well, I'm glad we were able to make some time to chat about that. I just want to give a big thank you to all of our panelists, Lee, Hector, and Sam. Thank you so much for sharing your expertise and your time with all of us.
So before I jump into just showing you widgets and things, turning on and off, I want to kind of give you an overview of what Rampart is and what it's trying to do so that you can kind of ground the discussion to follow. So really, Rampart is a technology that identifies unusual behaviors in your apps when they're deployed in a production environment. And we define unusual somewhat loosely. It's just something that you see in production that you haven't seen previously in your test environment. So with that in mind, there's really 3 steps in using Rampart. It's not as simple as just turning on a light switch, of course, right? Like you have to get our agent to attach to your application. That typically involves a few lines of configuration change inside of your Docker container or inside of the script that launches your app. But you don't have to change any of your code. Once our agent has attached to your application, you get an initial assessment of what's happening inside of the app. And we do this using instrumentation. So we go in and kind of like figure out what the app is doing, what kind of code regions it's hitting, what libraries it has, what interactions it's making with the host that it's running on, etc. And then there's this more rigorous workflow that you can enter, which we call training. And during training, we compute this structure that we call a minimum safe behavior envelope. This kind of gets at the notion that Sam was talking about earlier of, what is the least amount of stuff that we need to allow this application to do for it to function correctly in its operationally deployed environment. So during training, you drive the application through its paces in a representative test environment. And that allows Rampart, as it watches the system, to calculate this minimum safe behavior envelope. And then once you've reached a converged behavior model of the application, that means that if you ran your test cases 10 times after convergence, you wouldn't see anything new pop out of it. Once you've got to that converged state, you can ship this thing off into production. And thereafter, you can get alerts and notices and even blocking of especially egregious events that show up in your production environment. And that's the true value of what Rampart provides. It doesn't rely on heuristics. It doesn't rely on anything that's specific to certain attack vectors. The only thing that it's looking at is a delta between what it saw in your training and testing environment and what it's seeing in your production environment. And that turns out to be very valuable and very useful. So to drive that home, we have a demo prepared for you that I'll be going through. And there's a number of different components here. I'm not expecting you to memorize all this. I'm just going to give you an overview so you know what to expect as I move through the pieces. Really, there's two parts to the demo. The first part, we're going to look at Log4Shell, and we're going to do that running inside of a place that I call the Rampart Cyber Test Range. And there are a bunch of other apps in there beyond Log4Shell, and hopefully sometime I get a chance to do more of these demos and show more of the apps that we work with. But for now, we're going to focus on Log4Shell first because it's cool, it's relatively easy to understand, and it's truly horrible in its implications for security. So what we've done is we've deployed two different versions of a Log4Shell proof of concept application inside of our cyber range. One of them we're calling Log4Shell Red, and one of them that we're calling Log4Shell Green. They are the exact same application. They're running as Docker containers. So the jar that they're mounting is exactly the same. They're running on the same base image, but they are two distinct containers. And the only difference between them is that the green endpoint has our Rampart agent attached to it, and it has a converged behavior model associated with, with the way that this proof of concept web service is supposed to behave. So we're kind of starting at step 3 in that workflow that I showed you before. So we're going to focus on effect-oriented stuff in this demo. And again, hopefully in the future, I get a chance to either in blog form or live demo show what it takes to get our agent attached and what it takes to do that training process. But that's a completely different discussion from what we're showing today, which is once you have Rampart protecting your application, what is it you see and what is the benefit of getting to that point? There will be some stuff that runs on my laptop. I'm going to interact with a browser-based interface into the cyber test range so that I can get access to these services that are running inside of a Docker Compose, essentially. I'll be using a management client to interact with what we call the Rampart Polyglot server, which is essentially the server-side control component that tells these agents how to behave, what they should be looking at, what they should be blocking, what they should be allowing, etc. And I'll show you how we can do really interesting things dynamically with that interface. And then, of course, there's the SIM, right? That's the other component here that I haven't talked about yet. And in this demo, the SIM is just an Elasticsearch instance with Kibana sitting on top of it. So it's a pretty simplistic setup. But you can imagine this is something involving Splunk or whatever your SIM stack of choice is. We have ways of hooking into it. And we've got integration pathways with a number of different ones. But today we're going to focus on Elasticsearch and Kibana. And then also on my laptop is the second demo. This is one that is, I think, the cool one, which is Doom. So we're going to show you a fork of the Doom code base that our agent's going to attach to that has some really nasty stuff inside of it. And I'll show you how we can trigger that and what our agent does when it detects it and picks it up. So let's move on to the actual meat here. So give me 1 second. All right, so this is the SIM. And Daphne, can you just confirm that you're seeing this before I monologue? Yes. Okay, great. So as bad stuff happens in the next few moments, you're going to see events and telemetry pop up into this view. So for now, there's not much here. It just says that it's monitoring a certain number of hosts. In this case, it's only monitoring one host, and there's one active context. That means there's one application running, and we're monitoring its behavior continuously. And this is all running inside of the cyber range, kind of like the architecture that I just showed you on the PowerPoint slide. Now, the next thing that I have here, this is actually a website hosted within our cyber range. And this is essentially an attacker playbook that operators can use to go through and basically follow instructions, kind of like a guided hack the box tutorial type of a thing, where you can follow instructions to actually break into an endpoint. So what I'm going to do is I'm going to be copying and pasting snippets of code, snippets of scripts into this interface here, which is just a bunch of browser shells that are one way of interacting with our cyber test range. Now, there's other ways of interacting with it. For example, we have a VPN ingress option. This is kind of like the noob interface, though, and it's easier to use and more reliable. So I'm just going to hit it this way. But if you're imagining, like, how would I use my own tools or my own, custom setup, that's very much something that we've accounted for, and it is a possibility. So what I'm going to do is I'm just going to follow along as we break into a basically a web service that has a vulnerable version of Log4j inside of it that is susceptible to that horrible Log4Shell exploit that we heard about around about a year ago, back in early December. So there's really 3 steps to the attack. The first one is the easiest. It's the bad guy opening up something that's going to listen to incoming requests. So right now we're just going to use netcat LNVP on port 1234. And what I've done is I've set a timeout of 2 minutes so that this shell will die after 2 minutes. And I'm doing that so that I can reuse it to attack try to attack the green endpoint after I attack the red one. So what I'm gonna do first is attack the red endpoint, and I'll show you that it's it's very, very susceptible to this attack. And then I'll try to hit the green one in just a moment, and you'll see that it's definitely not. So I'm gonna start up the netcat listener, and now it's the bad guys listening on port 1234 for some kind of an incoming connection. The next thing the bad guy is going to do is start up an evil LDAP server endpoint. Okay, and this one's interesting, but it's critical to the way the exploit works. Really what this does is it serves up a malicious Java code object called export object. It's just a serialized object that's served over the wire. And what we have to do is trick this version of Log4j into reaching out over JNDI to this endpoint where this malicious object will be served up to it. And then once that client, aka the target app we're trying to attack, tries to deserialize that object, that's when the bad stuff happens. So it's going to run this nc command and pipe it into bin.sh. So it's basically going to give us a shell that we can use to exploit the system. And exploiting it is trivial. This is what made this attack uniquely awful. All you have to do is issue some kind of a request to the server that winds up being logged. And in this case, the request being logged just has to have this weird looking JNDI LDAP URL looking thing in front of it, but it's just a header, right? This is a key value pair that the server happens to be logging, just doing some low level logging stuff. So as far as we're concerned, the service endpoint worked correctly. It's a really simple REST API. In this case, just saying hello world. Again, it's a proof of concept. But if I go back to my bad guy shell, which is terminal 1, I just got a connection on this box. Who am I? Of course, this is a demo, so this is root. You could imagine in the real world you're not root, but either way, you have a foothold on this system. What I'm doing now is I'm catting out a flag file. And if you're familiar with Hack the Box or similar environments like that, there are essentially secret files. And by virtue of reading those secret files, you demonstrate that you've been able to compromise the system. So my shell just timed out there, but that's okay because I was able to capture the flag in that amount of time. So what I can do is I can capture, and then I'm just going to paste this random string, which turns out to just be some UUIDs that are appended together. And I have captured 1 out of the 23 flags in this cyber range. Like I said, we have tons of apps, and we're only looking at a few of them in this demo. So what that means is that the red endpoint was trivially exploitable, right? With a very small number of steps, I didn't have to customize anything, worked on the very first try. I was able to hose that endpoint, no problem. So now what I'm going to do is I'm going to run the second part of this attack. And again, there's no telemetry happening yet because I've only hit the vulnerable red endpoint. But now I'm going to do something different. I'm going to try to hit the green endpoint, which has our Rampart agent attached to it. So I'm going to do the exact same command. I'm just pressing up to get back in my history. NCLNVP on port 1234. Now I'm listening again. I'm going to fire up the exact same evil LDAP server as before. Nothing has changed there. And it's ready to serve my malicious export object on request. The only thing that changes in this demo, or at least in this part of the demo, is the endpoint that I'm making the request to. I'm replacing the red endpoint with the green endpoint, and this is the one that has our agent attached to it. So I go over here and fire off the request, and boom, I get back hello world just like before. So it's not immediately obvious that anything interesting or noteworthy has happened here. I also, if I go over here, I see that just like before, this export object class is being served up to the target application, which is interesting considering the fact that there's no incoming shell connection from the target machine back to my bad guy listen port. So the attacker, sometime between when that serialized object was served to the target app and when it ordinarily would have done the runtime exec that hosed the box, Rampart interceded itself into the execution flow of that application and prevented the bad thing from happening. So let's go and look at the telemetry view of this just to kind of show you what happened here. So there's a number of different things that have changed here. We see a breakdown of the events that Rampart just saw by their degree of severity. So there's a relatively large number of low severity events, and these are things that are caused by unusual execution of control flow, but nothing that's truly terrible or considered significantly divergent from normal application behavior. We see some medium severity stuff related to networking, and these events are related to the outreach to those two ports, like the JNDI LDAP ports that were used by the attacker to serve up that bad object. But what's really interesting here is this guy right here. So what I'm going to do is I'm going to apply a filter to get a view at just this one event and give you some insight into the kind of telemetry that Rampart produces. So first of all, this is a very severe thing. This one showed up as the highest level of severity that Rampart knows about. The corrective action taken was block, whereas with all the other events, the corrective action taken was just to alert on it. And the reason for that is we have a policy in place that says that whenever we reach a region of code that's trying to do a check exec, in other words, trying to spawn a subprocess, we should be very skeptical of that and block it if it's something that we haven't seen before in the trained application. So indeed, here we see exactly that. It's trying to run bin.sh, and there's a string associated with that bin.sh that's actually the command being run. Rampart does see that command, but it's only reporting here the fact that bin.sh is the executable running. And if we check out the full stack trace here, which again is not perhaps initially as interesting as the fact that something bad has happened related to code execution, but it is very interesting if you start looking into forensic analysis of what actually happened. And just like I said before, check this out. On one of the upper stack frames here, I see this export object thing, and I see init. And in Java, init is the like secret name that the Java compiler gives to constructors. So what's happening is that inside of the constructor of this malicious object that got served up to the target app via JNDI and LDAP, inside of the constructor is where this runtime.exec call happens. And that's what triggers this process builder start, which is what Rampart hooked into and said, hey, that's not something the app normally does. So I'm going to go ahead and block it because it's really sketchy. So that's a great example of the kind of thing that Rampart can save you from even without knowing about it ahead of time. When Log4Shell came out, again, back in early December, within 3 or 4 days, we had a proof of concept up and running, and Rampart blocked it out of the box the very first time we tried it. We didn't have to do any custom tailoring or anything like that to put in special heuristics. Just by virtue of seeing that there's a delta in application behavior, it was enough to catch this thing and stop it dead in its tracks. So what I'm going to do is purge out some of these filters, and I'm going to move on to the Doom demo here, which is one that's very near and dear to my heart and also seasonally appropriate, sort of, since we're going into Halloween season here. So what I did was I found a port of the Doom code base, which was, many years ago, released as open source. And so what I did was I found a port of that into Java. So some enterprising group of individuals put in the work to translate some C code into a form that runs and just entirely in Java. So what I'm going to do is I'm going to start up this version of Doom called Mocha Doom. Mocha obviously having the coffee connotation in Java. And I'm going to start this thing up. Oh, I only want to start one of these. And what we're seeing here is the splash of our application as it boots. And this is something that you would see some of this on the default application when it loads, but a lot of it is unique to the fact that Rampart is booting the application. So keep your eyes on the right-hand portion of the screen here, where those like the colored bars associated with severity will appear. And I can try to move this console a little bit out of the way so we're not looking at that too much. All right, so try to keep your eyes on this upper right portion of the screen as I interact with the game. So what's cool is that out of the box, I mean, who would have thought that this kind of tool would work on something like Doom without, without a significant amount of work, without doing a lot of code changes. In fact, we had to change none of the Doom code to get this to work. We just dropped our agent jar in there, and it's now talking to our Rampart polyglot server. And like I said, I already have a fully converged model of how Doom is supposed to behave. So I can go through the game. Everything is fully functional, including the sound, even though you're not hearing it. It's a little bit overwhelming hearing all the zombie noises and stuff when I'm trying to talk. So I can go through the game. I can kind of like speed run the first level a little bit, and hopefully at least some of the people on the call have played this game before. It's pretty old school, but it is one of the classic games. So that's all well and good. The next question is, what can I do in this application that would demonstrate the value of Rampart to detect unusual sequences of control flow or unusual interactions with the host system? And one thing that popped right into my mind, because I played this game as a kid, and I remember doing this as a kid, is cheat codes, right? In the original game, there was a function where you can type in strings, like a special string on your keyboard, and it will do certain things that make the game easier to play. Like it will turn on God mode, which makes you invulnerable, or let you walk through walls if you're stuck somewhere, or you can give yourself all the keys and ammo, and that makes it really easy to progress through the level, and without really actually needing to go through the tediousness of making your way through the maze part of the game. So what I'm going to do is I'm going to type in IDKFA. That's the cheat code to give myself keys and full ammo in Doom. So I'm on my keyboard right now. There's no terminal or any magic like that. I'm just typing IDKFA. Here I go, IDKFA. So I typed in that code, and you'll notice that a number of things have changed in my heads-up display. Like now I have this awesome 1992 grade rocket launcher thing, and I can bust up guys a lot better than I could with my weak gun that I had before. And what you see is right away, like within a matter of seconds, Rampart telling us that something sketchy has happened inside of the application. Now, these are all relatively low severity events, which means that Rampart saw them as odd, but they were close enough to normal execution that it didn't think they were worth blocking. And in fact, all of them show up as alert. So if I go down here and look at the telemetry, and I'm just going to kind of look for a magic string, I already know where the code is implemented. But one of these alerts that's generated tells you exactly where the cheat codes are implemented. So it's this basic block, sequence of instructions inside of the check cheat method in this m checks cheat sec t module inside of the Java code base. So that tells you exactly where in the code that the app has gone off the rails right now. So that's cool, right? Like we can tell when the app does something unexpected, and it works on Doom. But I wanted to make it even more interesting than that. So what I did was I put in another cheat code that didn't exist in the original source code. Again, this is open source, so it's pretty easy to go in and just muck about with the code to do something terrible that it wouldn't originally have done. So I added a new code, and it's ID pwned. And when I type in ID pwned, it's going to do a number of terrible things on my system. Not all of them will actually activate, but what we're going to do is look at the telemetry and see if we can reverse engineer what goes wrong. So ID PWNED. And I do see some red text up at the top there. Like that string is definitely not something that shows up in the original game, and I'll do it one more time. That red message that showed up at the top, that's definitely not something that ever shows up anywhere in the original Doom code base. What we'll see is in a number of seconds, Rampart's going to report on some really sketchy behaviors inside the application. And indeed, there he goes. The Rampart is telling us, I ran it twice, so there's two like blips of telemetry associated with this. It's telling us that there's some weird threading stuff happening. In other words, somewhere in the code, a new thread is being spawned, and that hasn't happened before. And there's also a whole bunch of new code units associated with the backdoor that I put in that we haven't seen before. So let's click on the execs, the highest severity ones. I'm going to apply a filter on this guy. Scroll down here, and let's look at what we see. So I see a check exec command calc.exe, and this is one that has an action of block. So Rampart blocked calc.exe from running. It also blocked cmd.exe from running, which is weird, right? But what my backdoor did was it tries to run a reverse shell using a pure Java methodology. So in other words, it's kind of like building Netcat in Java in the source code itself. It tries to phone that reverse shell home to the attacker box, which you can't reach because you have to be on the VPN to do that, the CTF range VPN. But what's interesting here is we see the stack trace where this occurred. So this is happening inside of a status bar lambda, inside of status bar.java line 880. And if I go to the diff, the GitHub diff of the code base, so here's status bar.java. There's only a small number of changes needed to make this happen. Let's look at line 880. Check this guy out. This is a very well-known one-liner for basically building a shell into Java code. And that's what Rampart picked up on without knowing anything else about the app ahead of time, without doing any kind of heuristic analysis or signature analysis, just because it never saw this code region get hit before, and it's doing something really sketchy. And we also see this, it's reading some environment variables here to find out where it should be phoning that shell home to. But what's really cool about this is I can go in through a dynamic management profile that's attached to this agent right now without rebooting it. And I can say, well, maybe that's okay to run. And again, you would never do this in a real production environment. There's no reason you would ever allow a suspicious check exec to happen. But just for S's and G's, let's fire this off. I'm going to commit this as a behavior override. It takes a couple of seconds to propagate to the app itself. But without rebooting the application, I'm able to enact changes to the security policy. And typically you would do this if you have false positives. That would be when this kind of thing becomes useful. Like if something is generating a lot of alerts, you don't want it to, you can do this as a way of filtering those alerts out. But at any rate, I added it here. So now I'm going to do ID pwned again. Type in ID pwned and check that out. calc.exe just spawned. And it's also spawning, it's trying to spawn that shell in the background, even though it's not able to reach the endpoint. So without us knowing that this was even embedded inside the application, Rampart previously protected us from it. And again, that's a great example of, in a legacy system, but you could use your imagination how that very much applies to things like web services and stuff that we use today, how Rampart can protect you from things simply by virtue of looking for unusual or unexpected events that occur at runtime.